Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to bring you the next part in our continuing series about the constellations. Last time we looked at Ursa Major and the Big Dipper. Today we're going to use the Big Dipper to find another constellation. In the spring, the Big Dipper is high in the sky after sunset. Look at the two stars in the end of the cup of the Big Dipper. The bottom star in the cup is named Merak, and the top star is named Dubhe. Imagine a line extends from Merak through Dubhe, and carry that line out until you reach the first relatively bright star you come across, about a dipper's length away. This is the last star in the constellation Ursa Minor, or the Little Bear. Ursa Minor is also called the Little Dipper because it looks similar to the Big Dipper, but smaller and dimmer. Just like the Big Dipper, the Little Dipper is made of 7 stars, 3 in the handle and 4 in the cup. The two dippers look like they are pouring into each other. The Little Dipper can be hard to see in areas with considerable light pollution, but most observers will be able to see the last star in the handle and the last 2 stars in the cup. Let's go back to that last star in the handle of the Little Dipper. This star is named Polaris, but you might have heard it called the North Star. It's a common misconception that the North Star is the brightest star in the sky. Polaris is actually only about the 50th brightest star seen from Earth. But while it's not very bright, it is very important. Earth's North Pole points almost directly at Polaris. NCP here is the North Celestial Pole, the spot in the sky directly above Earth's North Pole. If you drop a line straight down from Polaris to the horizon, then you have found true north for your position. It's a better bearing than a compass. I'm now going to switch views so we can see the entire night sky at once. North is at the bottom of the screen, south is at the top, and the perimeter of the circle is the horizon all around you. The center of the circle is directly above your head. As Earth spins on its axis through the night, the stars will appear to rise in the east and set in the west, just as the sun does. The stars will appear to circle the celestial poles, the projection of Earth's poles into space. Taking a long exposure photograph of the sky will reveal the paths of the stars. Most of the paths will cross the horizon at some point. However, Polaris will appear nearly fixed in the sky, and stars near Polaris will never set. From Michigan, the stars of the Big and Little Dippers are always above the horizon and visible every clear night. How many and which stars are in this special circumpolar region of the sky will depend on your latitude. Some simple geometry will reveal that Polaris's altitude above the horizon is exactly equal to the observer's latitude on Earth. On the equator, Polaris will just barely brush the horizon. And at the North Pole, Polaris will be directly overhead. This is why Polaris is the most important star in the night sky. Imagine it is a few hundred years ago and you want to sail across the ocean. Your course takes you out away from sight of landmarks. Only water stretches out to the horizon in all directions. How can you find your way with nothing but the sea and sky around you? If you know the latitude of your destination, you can sail north or south until Polaris sits at the altitude equal to that latitude. Now you only have to chart a course east or west, keeping Polaris at that altitude, to find where you are going. Polaris is one of the ways we know the way across the ocean. 450 light-years across the sea of space, Polaris itself is also quite interesting. Polaris is actually a triple star system, 3 stars bound by their mutual gravity. The brightest one, the one that we can see with our eyes, is a yellow supergiant star, about 4.5 times the mass of our Sun and a little hotter, but considerably larger, about 45 times the size. Polaris is a variable star, gets brighter and dims over a period of about 4 days as the star grows and shrinks in size. Polaris has not always been at the celestial North Pole, and it won't remain there for very long. Anyone who has ever spun a top knows that as the toy remains spinning about its axis, the top begins to wobble as it slows down. The axis begins to change its pointing, itself rotating through a circle. This motion is called precession, and all spinning things experience it, including the Earth. As Earth spins, its axis wobbles through this precession circle that we can draw in the sky. This process is very slow. One complete precession takes about 26,000 years. Earth's precession is hardly noticeable over a human lifetime, but over 200 generations, it's significant. Some 4,500 years ago, when the pyramids of Egypt were constructed, a different, dimmer star named Thuban was nearest the celestial pole. And 12,000 years from now, the very bright blue star Vega will be nearest to the pole. So if it's clear where you are tonight, go out and look for the Big Dipper. Use those last stars in the cup to draw out a line to the North Star, Polaris, and find Ursa Minor, the bear cub chasing its mother through the night sky. And consider that great clock of the universe that continues to tick overhead, and your place in the countless generations of people who continue to peel back its secrets. This is Brian from the Delta College Planetarium, wishing you clear skies.